Lou. Thank you for watching my video. What I'm showing here is my implementation of the seam carving algorithm that we've been asked to implement as part of our computational photography course. The seam carving algorithm comes from a paper called Seam Carving for Content-Aware Image Resizing. And basically the way it works is we're able to resize an image without actually distorting it. If you were to use some sort of commercial software, when you adjust the size of the image, maybe by dragging it, you could distort the size. And so we're going to show you an example here through seam carving how you can modify the size without messing up the image. So I'm going to go ahead and hit play on my algorithm right here, and as it runs I'll tell you about it. So figure 5 is our scenic image. Essentially what I'm doing, I'm reducing the height of the image by 100 pixels, which is about a quarter of the size, while maintaining the width of the image. So the final image will not be distorted at all, and that's as a result of seam carving. So to tell you a little bit more about this process, I did find the technical implementation to be challenging at times in this project, but the theory is relatively straightforward. The way this works is there's two components that really allow the seam carving algorithm to operate. The first is the energy function, and the energy function allows us to identify the unimportant seams in the image based on their energy, which is calculated as the gradient. So in our case we use the Sobel operator. The second component is finding the seams using a dynamic programming approach. Essentially the minimum cost is found by performing a cost calculation at each layer of the array. And then you store that result of the sub calculation and then you reuse it in the next layer to simplify the overall calculation cost. So while this is running, we can talk a little bit about how this actually works. So once I have my image, I run the gradient operation on it and I feed that in as a parameter for my seam finding operation. Once it takes in the gradient image, it follows the path and is able to find the lowest cost, so the least important seams, and then remove those. So this image that was just returned here is actually where all those seams came from, my 100 seams. Each seam represents a pixel. And so let me show you what the original image looks like and then what the final image output it looks like. So as you can see here, this final image is reduced by about 20% of its original size, yet it doesn't distort the actual content of the image, which is considered the scene. And so that right there is a demonstration of seam carving.